Welcome Year 12s. We're going to be looking at a few more differentiation cases. To start off with, we'll be looking at how to differentiate logarithmic functions. The logarithmic differentiation formula can be found in the formula sheet. The derivative of log x is 1 over x. This is one of the more tricky differentiation processes that we have to do. For example, if we wanted to differentiate log 2x plus 5, all we need to do when differentiating logs is to look at the terms inside the log bracket. The answer will always be a fraction, and the denominator, or bottom part of the fraction, will be the contents of the bracket. So I already know that my answer is going to be dy dx equals the numerator over 2x plus 5. To find the numerator, or top part of the fraction, we simply differentiate the contents of the bracket. When we differentiate 2x minus 5, remembering our power differentiation, we get 2. So our numerator is 2. So to get our answer, we simply put our numerator part of the fraction on top of the denominator to get dy dx equals 2 over 2x plus 5. Now we move on to trigonometric functions, which are just the circular functions of sine, cos, tan and their inverses. Once again, the formula sheet supplies all the formulas that are needed, and here is the formula for the differentiation of sine. The derivative of sine ax is a multiplied by cos ax. The term within the sine brackets remains unchanged, as the function changes from sine to cos. Then all we need to do is multiply the new function by the derivative of the term in the bracket. For example, let's find the derivative of sine 2 theta plus 5. The first step is to change sine to cos. Looking at the formula, we now need to take the number in front of the variable and put it in front of cos. In this case, we have 2 theta, which is equivalent to ax on the formula sheet. And bringing this down gives us 2 cos 2 theta plus 5. Notice that what's inside the bracket doesn't change. While that may seem complicated at first, have a look at our original term, sine 2 theta plus 5, and our answer, 2 cos 2 theta plus 5, and you can see that not that much has changed. Once you've got the hang of it, derivatives of this kind are pretty straightforward. Here is a similar looking formula for the differentiation of cos. The derivative of cos ax is the negative of a multiplied by sine ax. The derivative of cos is the same process as sine, except in the reverse. We move from cos to sine and add a negative. Here is the formula for the derivative of tan. The derivative of tan ax is a divided by cos ax squared, or a multiplied by sec ax. This can be proven through the use of the quotient rule, which we will learn about in the 5th calculus video. Basically, we again apply the same principle, where we maintain the same term within the bracket for the transformation, and then multiply it by the derivative. These basic differentiations of functions that we have looked at in the first 2 videos need to be mastered, so that more complicated forms of differentiation can be done during the exam. We will look at some more complex forms of differentiation in the next few videos. Thanks for watching and happy studying!